Master Strategies with Anil Kumar. Welcome to our series on trigonometry. The idea here is how do we learn a concept, build upon it, so that if in any competition, including IIT JEE, if a question comes on this topic, we are able to answer it. Now, this strategy of learning can help you be the best. We are talking about the compound angle where we know the formulas for sine A plus B, cos A plus B, and so on. In this video, we'll derive formula for cos 2 theta and then write cos 2 theta in different forms. For example, we could write them as cotangent theta. We'll take up an interesting question. You can say an equation to be solved and then another identity to be proven. So, kind of a mixed exercise where the objective is to understand a topic, build upon the learnings, and find the solution to a difficult question, like the one you see here at the end. Now, let's begin with basic formula concept first. We'll talk about how do we derive formula for cos 2 theta. You know what is cos A plus B, right? So that is the starting point. Cos A plus B, as you know, is cos A cos B minus sin A sin B, right? Now, if I put A equals to B equals to, let's say, theta, what do I get? I get cos of theta plus theta equals to cos theta times cos theta minus sin theta times sin theta. Now that gives you the formula for cos 2 theta equals to cos square theta minus sin square theta. Perfect. So we have a double angle formula right there before you, cos square theta minus sin square theta. This is our formula number 1 for cos 2 theta. However, there are two different formulas from here which we can derive. You could write cos square theta as 1 minus sin square theta, right? And you can write sin square theta as 1 minus cos square theta. So that should give you two different formulae, right? So let's get to these two formulae also. So we already know what is cos 2 theta now. Cos 2 theta is cos square theta minus sin square theta. Difference of the two. You know, sum of these two is 1. Now their difference, right? So from here, let's derive both. So in the first case, what are we going to do? We are going to split cos square theta as 1 minus sin square theta. So we can write this as cos 2 theta equals to 1 minus sin square theta. And we already have minus sin square theta, and that gives you 1 minus 2 sin square theta. So this is your second formula on cos 2 theta. Let me call this as formula number 2. And the next one, we will write cos 2 theta as cos square theta, writing sin square theta as 1 minus cos square theta. Remember to put brackets, otherwise you can do a mistake, right? Minus 1 plus cos square theta. You see that? So that gives you 2 cos square theta minus 1. So that is cos 2 theta, third formula. You get the whole idea. So these are the three formulae for cos 2 theta, and you see how they are arranged. Now, important thing here also is that you could write from here. From here, you can also write 2 sin square theta is 1 minus cos 2 theta. You get the idea? And you can write here 2 cos square theta is equal to 1 plus cos 2 theta. You get the idea. So you can derive more formulae from here itself. So it's a very important exercise. I'd like you to again perform all these operations which I've done. Understand clearly as we move forward. Correct. So now let's look into the next question, which is how do we write cos 2 theta in terms of cotangent theta? So we just figured out that cos 2 theta is difference of squares of cos, right? And sine. Now, I told you that sum of cos square theta and sin square theta is 1, right? So we could also write this as cos square theta minus sin square theta. Divide by what? You can think like divide by 1 doesn't make a difference, right? And what is 1? In trigonometry, we know 1 is cos square theta plus sin square theta. Makes sense, right? So there we go. We get cos square theta minus sin square theta in the numerator, cos square theta plus sin square theta in the denominator. Now we are looking for cotangent, right? Cotangent means cos over sine. So we are dividing by sin square theta every term. So we could rewrite this as cos 2 theta equals to, so we have cos square theta over cos square theta. So let's divide by sine. We want cotangent, right? So we should divide by sine square theta, right? So we'll divide by sine square theta to get cotangent. So we have sine square theta over sine square theta, right? And everything divided by cos square theta over sine square theta plus sine square theta over sine square theta. And cos over sine is cotangent. So we get cot square theta minus 1 over cot square theta plus 1, correct? So we have a formula for relating cos 2 theta to cotangent square theta. You get the idea, right? Same strategy can be utilized to write cotangent in terms of tan theta also. So you are understanding how we are developing the whole concept. Well, those of you who have less time and want to get complete knowledge in shorter period of time, you can always contact me for guidance. Our students are right there on the top, getting excellent marks and admission to the best universities. So let's understand this carefully. With another example, we have now cos 2 theta in terms of tan theta. You'll do similar thing, correct? As you know, cos 2 theta, as you know, is cos square theta minus sin square theta. You could divide by 1, which is cos square theta minus sin square theta over cos square theta plus sin square theta. Now, since you want to get tangent, what should you do? You divide by sine over cos is tangent. So divide by cos, right? So we get cos 2 theta equals to cos square theta by cos square theta minus sin square theta by cos square theta over cos square theta over cos square theta plus sin square theta over cos square theta, and that gives you 1 minus tan square theta over 1 plus tan square theta. Now these are very, very important results which will help you in solving many questions in trigonometry. I hope you're getting it right. So now we'll move forward. We have a question here which is, if 2 times cos theta cos x plus sin x equals to square root 3 over cos x minus sin x, then find the value of x where x is between 0 to pi. So we are given 2 times cos x plus sin x equals to square root 3 over minus sin x. Clearly, if I cross multiply, what do I get? So I'll cross multiply. So we get cos x plus sin x times cos x minus sin x, and we get square root 3 over 2 on this side. And this is cos square x minus sin square x. Clear? Which is square root 3 over 2. You see that? And that is cos 2x. Do you see how we have utilized our knowledge and so fast we came to a result? We need to now write down the answer within the domain 0 to pi. Now this is kind of tricky. When we say x is between 0 to pi, means 2x will be between what? Multiply by 2, 0 to 2 pi. Cos is positive, means we are looking for solutions in quadrant 1 and in 4. Since we know the cos rule, right? So we are looking for solutions in these two quadrants, correct? Square root 3 by 2, we can make a triangle, correct? So 1, 2 square root 3. We are looking for cosine, so that angle, which is pi by 6. So we know the related acute angle is pi by 6. So the other answer will be 11 pi by 6, correct? 1 less than 2 pi. So now we know that this 2x is equal to pi by 6 or 11 pi by 6, right? So x is what? Half of this, right? Pi by 12 or 11 pi by 12. So we get our solution. Do you see that? These are the two exact values within given domain 0 to pi. Do you see both the answers are within 0 to pi, right? 11 pi by 12 is less than pi. Perfect. So in this video, we learned how do we derive the formula for cos 2 theta. Based on that, we found what is cos 2 theta in relation with cotangent theta and tangent theta. And now we solve one trigonometric equation with the help of the concept. The whole idea is when you pick up a concept, get into details of related questions. Only then you will be in a position to answer some thinking and application questions in any competition. I hope this strategy works. We'll continue with this concept in the next video. Follow us on our playlist. Thanks for your valuable time and all the best.